Welcome to another edition of Masterpiece Theatre.
Hey guys, it's Chris Camaro, and I'm here bringing you another HP Tuners tutorial. This is not Masterpiece Theater, sorry for the corny joke, but that intro has a common theme with today's topic, which is the theme of fuel. And that's why I made this video, because I want to talk about how you can use HP Tuners to upgrade your fuel system electronically so that it can support higher horsepower when you're looking to add major power adders. And in particular, I'm talking to those people who might have a naturally aspirated muscle car like a Camaro SS, for example, and they may be looking to add like a supercharger, turbocharger, or some nitrous, or in some extreme cases, maybe they don't want to add any boost or spray at all. Maybe they just want to upgrade the internals and the breathing mods and all of that to such an extent that they get up into the 700 horsepower regime. I think it's pretty rare to see that. I haven't seen a lot of that, but certainly if you guys have done that with your cars, please post a comment because I'd love to hear about it. And in that case, this will apply to you too. So first thing you need to worry about is your fuel injectors. Fuel injectors obviously are fixed orifices. They can only flow so much at a given pressure, that is. And you don't want them to go static on you, which is to say you don't want them to be operating at 90% or greater duty cycle. Some people will say 85 or greater. They don't function very well at that stress level. So what I'm going to be teaching today is not really going to add any headroom to your fuel injectors, really. So just consider that a necessary upgrade that you're going to have to add. You're going to have to spend some money upgrading your fuel injectors if you want to get anywhere near the 650 to 700 horsepower range. And then you're going to have to obviously enter that injector data into your PCM. I've explained that a little bit in previous videos. I'll touch on it again today, but what I want to talk more about is the actual fuel system itself, the pump and the controller for the pump. So if you don't already know, the car has a fuel pump in it, and the fuel pump is electronically controlled. In a Camaro SS, it's 400 kilopascal pressure limit on that, and on the ZL1, which is supercharged already, it's got a 450 kilopascal limit, which is the physical limit of the pump, but it's electronically controlled. So you set that in the tables, and it sets the pressure, and then the duty cycle of the injectors is controlled in such a way that you get whatever flow that you want, right? So if you wanted to add a supercharger, for example, and you wanted to add another 200 horsepower to your 426 horse Camaro, getting up to whatever that is, 626, or let's just round it off and say 650 horse brake, then you're gonna be very close to that point where the fuel system is going to be at its limit. So let's just take a look at a couple of options here to see what's involved in doing that. So here's a website, this one in particular, HPP Racing. It's just a vendor I found in 2 seconds that sells a Ken Bell Booster Pump. And a booster pump is basically just nothing more than an electronic module that you place between your normal car computer and the fuel pump. So instead of the car computer controlling the fuel pump as it normally does, it gets intercepted by this module, which raises the voltage going to your fuel pump. So it gives your fuel pump extra voltage, which in essence gives it extra power to produce more pressure. Sometimes it doesn't always work the way it's supposed to because there are other limitations that you can't always account for from OEM to OEM, and we'll get into that in a bit. But in theory, it's supposed to just increase your voltage proportionally by a certain factor, and then you get approximately that much more pressure capacity from your pump. It stresses the pump more than it's supposed to be stressed. But the thing about pumps and motors in general is that they usually have a pretty healthy headroom, a pretty good safety margin, so it usually is not going to be catastrophic for your hardware. So this is one option that you can look at, and this is going to cost you, as you can see, about $300. So that's going to set you back. Now, what else could you do? Well, an even safer and more reliable option than doing this would simply be to replace your fuel pump altogether with a higher capacity one. So let's look at that. So on this page, you can see this is a stock ZL1 fuel pump. Now, for a Camaro SS, this would be an upgrade because the ZL1 fuel pump is beefier than the SS fuel pump. As I said before, it's got an extra 50 kilopascals of pump pressure that you're going to gain. So the SS has 400 kPa, this is 450. So that's 50 over 400, that's 1/8, 12.5%. So 12.5% extra pressure head right off the bat. That gives you a little bit of extra headroom right there. This module here looks like it costs about $250, but bear in mind you can't just replace this and go. You have to replace it, and then you have to upgrade your computer to match all the new ZL1 pressure parameters, and everything have to be upgraded as well. Somewhere between $200-300, whether you get the booster pump, whether you get the fuel pump upgrade, you're going to be set back a few $100. So, I guess a point of what I'm getting at here is how can you avoid this setback in cost? Is there another way? And the answer is kind of, yeah. Depending on how much extra horsepower you actually want. Before I get into that, let's take a look at a little case study here that I found. So this is a screenshot. It's not my screenshot. It's a screenshot that another car enthusiast posted for his Camaro, showing his fuel system tables. And the reason I'm showing this, if you take a look at, for example, the bottom table, let me see here. Yeah, the table at the bottom over here. So this is the maximum pressure table, maximum desired pressure table under the fuel tab in HP tuners. So what this tells what this means is basically on the top axis you have fuel flow rate in pounds per hour. So that's how much fuel is actually flowing, and that's compared to let me see here, the pressure. So for a given flow rate that's realized, the computer will command a certain pressure for the pump to operate at, is what this means. So for example, if you look at the 95.2 cell over here, what this means is that when the fuel flow is 95.2 pounds per hour, command 432 kilopascals of pump pressure. So what you'll notice about this table is that it starts high at 448 and it actually goes down. So towards the end of the table here, you're getting numbers like 360, etc., and it drops from 448. So what this means is that the more fuel that's flowing, the lower the pressure that the computer is commanding of the pump. Now, the more astute among you will notice right away that this is kind of counterintuitive. Why the hell would you want less pressure when you need more flow? It just doesn't compute, right? It doesn't make sense. And I don't have an answer for that. Nobody that I've talked to has an answer for that. Nobody understands why GM did this. There might be a good reason for it, but I don't know what it is. All we do know is that this is a bottleneck, because when you need the pressure the most, it's when the fuel system is about to fail on you. It's when you're commanding the most fuel. So that's when you want the pressure to be high, if anything. And that's not what's reflected in this table. Now, even though this isn't my table, this is what my table looked like. And this is the key, or the secret, if you will, to getting a little bit of extra headroom. Let me try to illustrate the point a little bit more clearly here now. If you take a look at this diagram, this is from the same user. He's got a Whipple supercharger on his 2010 Camaro SS, which has an LS3, of course. And he's also got an MSD booster pump, which is that, well, MSD is a different brand, but same idea, right? It's that voltage booster. So he's got the booster pump, which is supposedly giving him this extra fuel headroom. But look at what's happening. He gets to a fuel flow rate of 175 pounds per hour, and look what happens. He's got the computer represented by this blue line that's dropping here. The computer is commanding less pressure, just like the table that I showed you 2 seconds ago was indicating, right? So the computer is commanding less pressure. The actual fuel pressure, which is logged in red, is following that naturally. And look at this purple or gray line or whatever it is. This is the duty cycle of the fuel injectors, and it's going up, which also makes sense because when the pressure drops, the amount of fuel going through the fuel injectors also drops. So when the car is starving for fuel and it wants more fuel to keep the AFR constant, it panics and it opens up the fuel injectors as much as it can to try to get more fuel just by opening them up for a longer period of time. That's why the duty cycle is going up. So this is counterbalancing the drop in fuel pressure. Had the fuel pressure not dropped, the duty cycle wouldn't need to go up like this. So this is the problem that we're going to be addressing, and this is why it's important to tune your fuel system using HP tuners, using this technique. If you're interested in, and by the way, this will help people even if they've upgraded their components, even if they've bought an upgraded pump or a booster pump like this guy, right? He bought the booster pump, which is supposed to give him some 75% extra fuel. Well, so much for that, right? It didn't seem to do jack shit in his case. His fuel dropped off a cliff. So sometimes even these gadgets that are supposed to give you all these gains and stuff, they don't work as advertised. And that may not be the product's fault. It may not be the booster pump that's to blame. It could just be interlocks in the hardware that you know are for your car, or the way it's connected, the way the computer controls it, etc., etc. So you can't always rely on one method. Sometimes you need to have a couple of things working in tandem. So just going to take a quick deviation, talk about fuel injectors for 2 seconds, because that's one thing we need to get out of the way before we start talking about messing around with the tables. So here's just an example of upgraded fuel injectors. These happen to be the ones that I bought for my car. They're from Deutschwerks. I don't know how to say it. German company, I suppose, and they're pretty good. What you want to do is you want to download the data sheet that comes with these, because you're going to need to use the new data to update your fuel injector tables. Because whenever you change a component like fuel injectors, it throws everything out of calibration. Your VE table, all of that will be garbage unless you recalibrate with the data that's provided with these new injectors, because their flow characteristics are entirely different, and therefore all the flow characteristic data needs to be updated. So let's have a look at that real quick. So here's just an example of the part you were just looking at and the chart that goes with it. So it's got, you know, your nonlinear range here for very low duty cycles. It's got your linear range over here. You know, you've got your static, which means, you know, wide open data at different pressures. So in case you have a 4-bar fuel pump, which I do, then you would use this row here, and you need to update the data in 2 locations. So let's go to HP Tuners and check that. So back in HP Tuners, there are a couple of locations that need to be addressed. First, you want to go to up at the very top. Up at the very top, you want to go to Engine, and then you want to go to Fuel, and then General, and then you want to go to, for example, where it says flow rate here, flow rate versus pressure, and that'll contain a whole bunch of data that correlates directly to the data provided in that sheet, and also minimum injector pulse. There's some offsets that you have to set as well, short pulse limit, things of that nature. If it's not provided directly on the data sheet, you can always call the company up or email them, and they will provide those numbers for you. Although they usually line up with HP Tuners pretty good, because HP Tuners is pervasive enough of a software package that all the manufacturers are very familiar with it, and they're aligning their data sheets to match. So you shouldn't have too much trouble with that. Now, once you've done that, then you want to get out of that section there and go to the fuel system tab. Here's the fuel system tab here. And then once in the fuel system tab, you're going to go to your fuel control module, and this tab will only exist if you purchase the upgrade for it, provided that you did so when it was actually being charged. I think it's free now, so depending on the case, you may not have even had to pay for it, but you need this tab, which is an upgrade option in some cases. And then you want to go to all of the tables in here that correlate to what you just upgraded in the other engine section. So, for example, flow rate versus pressure. There's a table just like the one that you filled out. And again, you can pull the data off the data sheet and just fill it in here and interpolate the difference. Not all of the entire row is going to apply. Some of it will be inadmissible. So, you just line up the data that you have information for, and interpolate what's in between, and don't worry too much about the rest. Now that we've kind of dealt with the fuel injector aspect of the tuning and gotten that out of the way, I want to move back to focusing on the fuel pump again. So if you haven't already guessed, the whole goal of what we're trying to do here is we're trying to get extra performance, extra margin, extra headroom out of the pump in the same way that the mechanical upgrades do, but we're going to do it programmatically by tuning. So there's a couple of ingredients that we need to make that a reality. So let's check out the first step in the process here. So first we're going to get out of this, and we're going to go to the tab that says System. And under General, which is over here, you're going to notice a button called Fuel System Voltage Minimum, and click on that, and you'll notice a two-dimensional table. The top axis is, of course, intake air temperature, as it says, and the side axis is actually your flow rate, your fuel pressure flow rate, if I remember correctly, and it's in grams per second, I think. So this actually lines up with one of the units that's expressed in most of your injector tables that you could, by most of the companies that you're going to be working with, where you get your injectors from, they should have those units as well as pounds per hour or whatever. So I think this is grams per second. But in any case, as you can see, they've got different rows for the different flow rates, and you have different voltages. Now, my table, I've already put 15s all over the place, but they weren't always like that. I think the default was 10.5. So what this table tells the car is this is the minimum voltage that is permitted for the fuel system to function. So the fuel system must have this minimum voltage, right? Now 10.5 isn't that much. From what I've read from sources like Janity Racing, and it's been confirmed by other sources as well, tends to be the case that anything up to 14.5 will actually increase the, it'll actually work. It'll actually increase the minimum voltage up to a point. Anything past 14.5 doesn't seem to register as a valid number anymore. It doesn't seem to do anything. So in my case, 15 is just as good as 14.5. You can put 14.5 if you like. But basically, it's better than the 10.5 that was there before. So all this does is prevent the voltage from being a bottleneck, from being a limiting factor. It prevents a scenario where you are under wide open throttle conditions with your supercharger at 12 pounds of boost, for example, and you run out of fuel and have a catastrophic failure, and then check your scan data later on and find out that your voltage was depressed, and that's the reason why you lost fuel pressure. So this prevents that as much as possible by raising the system voltage to its maximum, so that the fuel system can operate at that elevated voltage. And this is very much the same thing as a booster pump. A booster pump is a hardware add-on that raises voltage, and this is a software setting that raises voltage, albeit by not the same degree. This is only raising it by a couple of volts. Booster pump is going to give you a lot more than that. But like I said, this is not like a super solution. This is just like a little cheat, a little tweak. So if that's all you need, this is what's going to get it to you for free rather than paying for a booster pump, right? Step 2 now, we're going to go back to the fuel pressure, the FPCM table. So let's get rid of this and close this down too, and go back to fuel system where we were before. And go back to your fuel control module tab here. And as I kind of alluded to earlier, the only real important table in here that we want to deal with is the one called max desired pressure. As I said before, the fuel injectors are going to necessitate screwing with a couple of other tables here, but really I should say that there are 2 tables that I changed in this tab. One of them was minimum desired pressure up here. So if this isn't at least 400, make it so. And then under the max desired pressure table, this is that one that I showed you earlier from the other user, where the numbers were all going down with increasing fuel flow pressure, fuel flow rate. So you want to fix that. So rather than allow it to ramp down, just change it to the maximum pressure that the pump can handle. In the case of the Camaro SS, the pump is rated for 400 kilopascals. In the case of the ZL1, it's rated for 450. So whatever the case is for your particular vehicle, just determine what the hardware rating of the pump is and change all the values to the same number, to the maximum. Also, I find another reason why it's good to change all the numbers to the same value is because the more constants you have in your equations, the fewer variables exist and the fewer things you have to tune. So it's nice to have the fuel pressure constant all the time, because that just means that the computer won't be struggling trying to calculate air-fuel ratios with different fluctuating fuel pressures. The more stuff that doesn't change, the easier it is to manipulate the rest of the data with minimal error. It just shrinks the error even more. So always a good idea to keep as much steady as possible. So that's what I did there. And that's really the essence of the change. Let's take a quick look at the repercussions of what that is going to do. So once again, going back to that case study from earlier, this is the same user again showing us a scan of his car while he was under wide open throttle conditions. And this is a little different because even though he has a booster pump, he disconnected it for this run just to see what was possible with the changes that he made to his tables. So he's got it. He's got a cursor line coming down right around here, which is approximately where it is. This yellow line represents his air fuel, his wideband AFR reading, and you can see it gets all crazy over here because the car ran out of fuel at this point, which is this green line down here shows you the increasing duty cycle of the injectors, and this descending pink line here shows you the dropping fuel pressure. So really the fuel pressure started to drop a little bit earlier, but it wasn't a problem until the duty cycle maxed out. So for all intents and purposes, everything was good up until this point right here. By the way, nothing happened to this guy's car. His car was fine, which is lucky because you could have problems, but fortunately he didn't have any problems. And he was putting out close to 700 horsepower with this car, even without the booster pump, right? So just the changes alone pushed him into deep 600 territory. all because it extended the range of the pump just that much more, because the pressure was literally falling as a result of the mechanical limits of the parts rather than electronic limitations imposed by GM engineers. So by doing the changes that I've already illustrated to you, upping the voltage and changing that max pressure table, which up until now we haven't really had access to until HP tuners unlocked that feature and really gave us access to that very important critical table. Now that we have that to play with, we can sort of extend this line as far as possible. So by the time he started running out of fuel, where he's got this cursor here, that's 6,500 and change, 6,600 for all intents and purposes, which is pretty damn good considering. So he basically got his entire power band with I think about 9 psi of boost without running out of fuel. And this is basically the point, right? This is like when you are on the edge and when you need that extra little bit of horsepower. And as I said, he's pushing upwards of 700 horse, and you don't want to have to go the extra mile of spending several $100 in upgrades. This is one way that you can cheat that and get that extra headroom that you need. Just to backtrack a little bit and wrap up at the same time, this is all based on the premise that you are trying to target 650 to 700 brake horsepower, which equates to just over 550 wheel horsepower, maybe 550 to 575 wheel horsepower. Ordinarily, that would be kind of off limits with a stock setup, but with these simple changes that you can do to your HP tuners, given this tutorial, if you follow it, and you have your fuel injectors and your spark plugs and all your other supporting hardware already dealt with, you can cheat that extra little bit of horsepower that you need and get away with a bit of a cost savings there, and it shouldn't be a problem for you. So love to hear anybody who has tried this and what the results were. Please post your dyno graphs and your HP tuner scans on the comments section. Feel free, and please support my channel if you like the video, and if you want to see more like this in the future, hit that green thumbs up in the bottom right corner of the video. That'll be greatly appreciated, and I'll see you guys next time. Have a great day.